Okay guys, so I'm just going to go through the different manufacturing processes we went through today in the lesson. Just so again, there's a list of them there. You don't need to know that just yet, but you can see there is certain ones for thermoplastics, certain ones for thermosetting plastics. Again, the thermoplastics tend to be quicker processes because thermoplastics set once they go under a certain temperature. Thermosets will not set until all the cross-linking is complete. Okay, so the first one we looked at was calendering. So calendering is essentially when you want to make sheets of something. Okay, so you have cling film, building plastic, silage wrap, damp-proof membrane. Okay, and it goes through all these different known as calendars. So it consists of a series of heated rollers known as calendars. A softened plastic, so it's rolled by the rollers. So up here you would have pellets being fed in. So again, essentially they're essentially like beads of plastic being fed in, and they get melted by the rollers. And then again, as it goes through the rollers, it gets thinner and thinner because the rollers are closer together, and it slowly decreases in temperature. Each of these rollers is at a different temperature, slowly letting the roll, slowly letting the plastic cool. Okay, I just want to show you again for the assignment. What you can do is draw something along the lines of this. So again, it will have one roller, two roller, and you can draw maybe another roller here. Okay, so you have your plastic is here like this. It's fed down through the roller, goes around this roller. We'll just do it nice and simple just for the time being, calendering, and then it gets rolled up into a ball. Okay, please draw it a bit better than that. But again, I'm just trying to draw a freehand, something along the lines of that. Okay, so just a few calendars. You don't need to go crazy with the drawing there. Again, don't forget in the drawing you need to include a drawing, discussion on what's going on, and the products. Injection molding. Again, I just want to go through this now that I have a pen. It might make life a bit easier. I've included a photo on the thing, again, just numbered. So what's happening here is you have your hopper. These are beads being fed in. What happens is it comes down into the chamber, and as the screw turns, the helix, the screw isn't moving, but the material that's around the screw is being pushed down. It's going down the chamber. As it goes down the chamber, the heaters heat it up, making it molten. So it's, by the time it reaches here, it's pure liquid. Once that plastic reaches here, I'm going to go to green. Once it reaches here, you can see this ram here, the entire screw jolts forward and injects the material into the mold. Okay, once it goes into the mold, it fills the area like that, fills it like that, and that's it done. Then your split mold opens and you have your finished project. Okay, so again, you can see there, so it says, look at the screw thickens. The reason why see the way the screw, it tapers slightly. See the way it's at a slight angle. The reason it tapers is it puts pressure on the material at this point here, pushing out any air pockets or anything like that. Okay. So you have injection molding. So again, products, CD cases, again, very wide range of products. Very wide range of products. Pellets fed into the chamber. Again, you can do what I did and number them. So 1, 2, 3. That's what I did in the photo. Just number them. So again, 1, 2, 3, 4, and then you have 1, 2, 3, 4. I think it is. Sure, so it's all the one on here. So again, and you have all your different points there. So thermoplast fed in. As it comes into the chamber, the screw moves it down. As it goes down the chamber, it's heated, so it becomes liquid by the time it reaches the end. Then the whole screw jolts forward, pushes the liquid plastic into the mold, and then it returns to its original position and screws again. Okay. The last one we looked at was extrusion. Same principle. Okay. From here back is the exact same principle. Bar, it does not jolt forward. There's no jolting forward, it's just consistently moving and pushes it through a die. So a die could look something along the lines of this. Again, that's for a circular one. You could have a square die. You could have, again, for a gutter, would have to look something like that. It depends. Okay, so the die, just again, whatever you want. This is the die here, and it gets pushed through. And then don't worry about the cooling tank or all these, or the cutters or anything like that. It gets pushed through, and then you have a profile of, like, it could be a pipe, or it could be a square or a nylon bar or something like that. Because that's the only difference between injection molding and extrusion, is this die at the end. Okay, and that's it, guys. So we'll go to, we did blow molding as well. So in blow molding, what happens is, So blow molding, it's used for bottles. It's used for bottles and any hollow object. Because what happens is with blow molding, there's air blown in to push it into shape. So again, you can see, so hollow objects, again, it's made, I'll go through this first and then I'll go through the points. So what happens is you have a parison. So the parison is what it's called. So it's like that. It's literally like a pipe. It looks something like that. Then in this stage here, what happens is the pipe, it gets pinched at the bottom here. See the way it gets pinched there? It gets pinched at the bottom. And now air is getting blown through, and the air is going to push it like a balloon. It's going to push it to all the extremities of the mold. And then you get your finished product once it sets. The mold opens, letting it out. Okay, so you have it there. So again, an extruder, don't worry about that. All you need to know is there on that sentence. Don't worry about the extruder. So the bottle, so semi-mold and the parison. The bottle's mold is clamped around the parison. So the mold is the split mold here. So again, the base gets pinched to stop the air from flowing through. The parison gets blown up like a balloon and fills the mold, and then it's let outside. Okay, and that's it. And then we'll go through a few more next week. Okay, guys.